Welcome to Concepts of Programming Languages. My name is Professor Caliph, and today I'd like to start talking to you about parameter passing. Notice that this is part of a more advanced series, so I do assume that you have some familiarity with programming and have done parameter passing and understand something about how it works in some particular language. Our goal today is to look at the broader perspective of parameter passing as it's done in a wide variety of languages. This is just an introductory video where we're going to look at a few issues. Then in later videos, I'm going to get more in depth in the various mechanisms that we use. First, we should talk just a little bit about what it is that we pass parameters to. The generic term for that is generally subprograms. We also call them subroutines. Some languages actually just use that term for this. Functions is probably a very familiar term to many of you. Procedures is another term for certain kinds of subprograms. And of course, if the subprogram is part of an object or class, it's often referred to as a method. Basically, what we're interested in is we have a unit of code that's getting called by other code, and we're able to pass information of some kind to it, and possibly pass information back out. I want to talk a little bit about some terminology when we're trying to be very specific about how parameters are working. We need some ways to distinguish between what we call formal parameters, the description of what can be given to the subprogram that we find in the subprogram definition. When we're talking about what we're allowed to provide, that's the formal parameter. Then we have actual parameters. That's what we actually pass in. And we find that in the call to the subprogram. We also have the term argument, which sometimes is just considered a synonym for parameter in general. But when we're being really precise, we consider argument to be a synonym for the actual parameter, the thing that gets passed in. One of the issues that programming language designers have to deal with is matching the formal parameters and the actual parameters, so that when we make that call, we know which argument is supposed to be used for a given formal parameter in the actual running of the subprogram. Now, typically that's done by position, which most of you are probably sitting here going, well, obviously we do it by position. That is fairly obvious, but was a decision that somebody had to make at some point. And of course, we're familiar with the notion that if we define this function, compute sales tax, that takes two double parameters, and we have a call to it, that first parameter, the 10.69, is going to get matched up with subtotal. And the second parameter, the 0.0825, is going to get matched up to the tax rate. Fairly straightforward. The reason it's so common is that it is pretty easy to understand, makes a lot of sense. We do have one variation called default arguments that some languages allow for. For example, C++ and Python both allow for default arguments, while Java does not. The idea is that when I'm actually defining the function and setting up the formal parameters, I can specify a default value. And then if a value is not provided when the function is called, that default value gets used. So if we call compute sales tax the same way we did before, specifying a tax rate, then we will actually get the specified value. Tax rate will be 0.0825. But if I call compute sales tax and don't provide the tax rate, then we'll get the default value of 0.075. It's important to remember that default arguments do work positionally. So if I have a function with 3 parameters and parameters 2 and 3 are both default, there's no way for me to specify the third parameter's value and just get the default for the second parameter. Now, it's fairly obvious here they're all integers, so how would the compiler know? But this is true even when I have different types. So I have this do stuff with an integer first parameter that doesn't have a default, a character second parameter, and a float third parameter. If I try to call it and pass in 3.5, it's not going to say, hey, that's a floating point number. We should make it be param 3. What's going to happen is it's going to say, okay, you have 2 parameters, so those match up to positions 1 and 2. 2 is a character, 3.5 is not an acceptable value for that, so I'm going to get a type error. So as long as I'm using defaults, if I want anything specified, everything before it has to be specified, even if the defaults would work just fine. There are a few languages that allow us to sort of get around that problem and have something called keyword arguments. The idea here is that I'm going to use the keyword, the name of the variable, in my actual arguments. So if we look at our do stuff example, the second one, and move that to Python, I have the same thing. I've got a param1 that's a positional argument only. I haven't given it a possible value, so I have to specify that one. But then I have two others. I could do this positionally, so if I just specify two values, I'm going to get them in param1 and param2. But I can also use this keyword notion where I can say, hey, I've got the 4 that has to be done positionally, but then I want to specify that param3 is going to get the value 3.5. In that case, param2 will be its default value of A. Hugely valuable when you have functions with lots and lots of parameters. So for instance, in machine learning libraries in Python, you often use this because there will be a slew of parameters to an algorithm, and you may want to adjust just a few of those and use the defaults for all the others. So the keywords allow you to do that very, very easily. There are languages where they only have keyword arguments. They don't do things positionally. And so you have to specify the keyword always. Python's sort of unusual in that it allows both the default approach with positional arguments specified and the keyword approach. So it's sort of maximally flexible. Before I wrap this up, I do want to talk a little bit about the purpose of parameters. The most common purpose of a parameter is to provide information to a subprogram. And that's probably what you think of as what we do with parameters, is they're giving data to the subprogram to tell it what to do. However, there are times when what we're interested in is passing information back out of the subprogram, possibly doing both in and out. Notice that there's a lot of people who will frown upon the use of parameters as a way to get information back out. They'll say you should only get information by returning it, but it's still used widely. And in concepts of programming languages, what we care about is, what do people actually do? We may talk some about what's better, what's worse, but we really want to talk about what are the mechanisms that we do to support the things that programmers actually do. And there are places where it seems highly appropriate. For example, consider the case where we want to update the value of a parameter. And of course, I can require that someone pass the value in, I modify it, and then I return it, and then you have to actually catch that return value and store it in the right place. But if the purpose is just to update this value, then it makes the most sense to make the parameter modifiable in some way. So as we look at different mechanisms for passing parameters, we're going to be interested in both giving information, but then also how that impacts things back out. And in fact, that's going to be a really important piece of what we're interested in, because that's where a lot of the differences lie. Okay, so as I said, I'm going to have some follow-on videos that talk about mechanisms. When we talk about all these different approaches, there are a couple that you're probably already familiar with. So you probably know about pass by value, where we simply copy a value into the called function from the calling function, work with that copy, and nothing changes back in the original. As well as pass by reference, where instead of passing a copy of the value, we pass the location of whatever it is we're passing. And then whenever we reference that parameter in the called function, we're going to go to the location where the original is and make changes there. We'll talk about those in a little more detail, as well as a variety of others in these subsequent videos. I hope that you'll check those out if you're at all interested in the wide variety of ways that we can pass parameters. Thanks for watching. Hope to see you next time.